a lot of times we can use the properties that we know about parallelograms to actually show that certain figures are, in fact, parallelograms. So certain quadrilaterals are parallelograms. Let me show what I mean with an example that sort of has an algebraic flavor to it. So let's show that the quadrilateral ABCD is, in fact, a parallelogram when x is 5 and y equals 2. So here's the picture, and you can see we're given the lengths of the various sides of the quadrilateral in terms of these unknowns. But if we're told that x equals 5, it's no longer unknown, now it's known. So let's see what happens. If I put in 5 for x on BC, then I see 15 for this length. And if I put in 5 for x here in AD, 3 times 5 is 15. So I see that this length is equal to this length. Now, that's not enough to be a parallelogram, but we're given that y actually is equal to 2, so I can figure out these lengths as well. If I put in 2 for y, I see 6 times 2 is 12, minus 1 is 11. So this is 11 right here. And what about here? When I put in 2 for y, I see 8 plus 3 is 11. Well, since I see that opposite sides of this quadrilateral have actually equal lengths, so 11, 11 for this opposite pair, and 15 and 15 for this pair, then that is enough for us to conclude that this, in fact, is a parallelogram. So that's a great property that implies parallelogram-isms, which is that, in fact, if the opposite sides have the same length, so both pairs. Neat. Another example, here we go. Show that the quadrilateral EFGH is a parallelogram for z equals 10 and w equals 15. So here again, we see this sort of complicated looking quadrilateral, and now the angle measures are given in terms of these unknowns. So let's actually insert the values that we have for the unknowns and see what happens. So if I let z equal 10, then here, if I put in a 10, I see 7 times 10 is 80 plus 12 is, 7 times 10 is 70, and 70 plus 12 is 82. So this has a measure of 82 degrees. Okay, that's not enough to make it a parallelogram, of course. But, oh wait, here's a z here too. So here, this z is going to be what? Well, when I put in 10, I see 110 minus 28. Well, 110 minus 28 actually is 82. Well, that's looking good. So these two angles actually have the same measure. So that's looking really promising. But let's see what happens when we put the w equals 15. Well, if w equals 15 into here, then I see 6 times 15 plus 8, which gives me 98. 98 degrees. Well, let's see. Can we conclude anything here? Well, actually, we can. Because check it out. If this is 98 and this is 82, what happens if I add these two measures up? I see 180 degrees. So, in fact, these two angles are supplementary. And if I have two adjacent angles being supplementary, then I know that these two sides are parallel. So since these two sides are parallel, then, in fact, I know that since this is 82 degrees, then this angle here must be 98 as well. Why? Because I've got parallel lines. This is a transversal. If this is 82, then this has to be supplementary to 82. So that gives me that. Well, now I see that these opposite angles of this quadrilateral have equal measure. So these have the same measure, these have the same measure. These opposite angles are congruent, and so therefore it is a parallelogram.